In this video, I'm going to show the derivational proof of the fourth and the fifth equation. As we already know, these five equations are the equations for motion with constant acceleration. So for this video, I'm going to only consider the fourth and fifth equation. So here, for getting the fourth equation, I'm going to use the basic definition of average velocity. So what is the definition for average velocity? The average velocity which is equal to the displacement over time. Displacement over time. So if you want to write the formula, we know delta x over time. Now I'm going to calculate the average velocity. So how we can calculate the average velocity? So if you want to calculate the average velocity, you need the initial velocity and the final velocity. So I'm going to take the average of the two velocities. What are they? Initial and the final. So initial velocity I'm going to take as v0, and the final velocity I'm going to take as v. So how we can take the average? We have to add these two velocity and then we have to divide by 2. So this is our average velocity. And here for the displacement, we know the formula, it is delta x. And the time value I'm going to, that means the change in time, I'm going to take as t. Now I'm going to rearrange this equation. So how we can rearrange this equation? So I'm going to make the equation, I'm going to frame the equation in terms of displacement. So therefore the displacement delta x, which is equal to the average velocity v0 plus v divided by 2, and then I have to take this t to the left hand side of the numerator. So by that my t will come here. Am I right? And what is our displacement here? Final position minus initial position. So here my final position is x, my initial position is x0, which is equal to the average of two velocities, which is nothing but the final plus initial divided by 2 multiplied by t. And this equation is nothing but our fourth equation. So we just go back to the slides. We can just see the first one. The first one is nothing but the displacement, which is equal to half multiplied by v0 plus v multiplied by t. So this is the derivation proof of this equation. For the second one, what I'm going to do, I'm going to take the first equation as well as the second equation here. So better I can write this equation here. The first equation is v, which is equal to v0 plus at, where v is the final velocity and v0 is the initial velocity, a is the acceleration, and t is the time. So what I'm going to do, I'm going to modify, I'm going to reframe this equation in terms of initial velocity. So v0, which is equal to v minus at. This plus at will go to the left hand side. By that this equation becomes v0, which is equal to final velocity v minus acceleration multiplied by t. So I'm going to take this equation as the first equation. Now I'm going to write the second equation. As we already studied the second equation, the displacement, that is x minus x0, which is equal to the initial velocity multiplied by time plus half acceleration multiplied by the time square. This is our second equation. Better we can just go back and we have a look of the second equation. So the equations what I wrote now is nothing but this equation. Now what I'm going to do, I'm going to take the first equation, then I'm going to substitute the first equation here. That means in place of initial velocity, I'm going to take this, I'm going to substitute this one here. If you substitute, what will happen? This equation becomes x minus x naught, which is our displacement, which is equal to, in this place of initial velocity, I am going to substitute v minus at. So if you substitute, what will happen? V minus at multiplied by this time. And then the rest of the part I am going to write plus half at square. Now I'm going to multiply this t inside. So by that your equation becomes Vt minus at square plus half at square. At the left hand side is x minus x naught. Now you can see the right hand side. Here we have minus 180 square, because here it is 180 square. Am I right? But here we have half 80 square. That means minus 180 square. Here indirectly it says it's 1. Am I right? So minus 80 square plus half 80 square is nothing but minus half 80 square. So what I'm going to do, I'm going to write this equation again, x minus x naught, which is equal to this Vt. I'm going to write as it is. But here, after you subtract this 180 square with plus half 80 square, this becomes minus half 80 square, and this is nothing but your fifth equation. So this is the derivational proof of the fifth equation. So how we got this equation? We got the fifth equation with the help of the first two equations. And here, this is one of the important equations. We always use these equations for solving the numerical question in Physics 1 chapters. So this is the derivation proof of these two equations. So if you just go back to the previous slides gives the information about the fourth equation derivation, and then this slide indicates the fifth equation derivation. Thank you. If you like this video, please kindly subscribe my channel, and if you have further comments, please share your comments, share your thoughts through the comments, and please kindly share the link to your friends. By that your friends also get some information. Thank you so much.